Hey guys, welcome to the lesson on trigonometric ratios. That's what we're going to be covering over the next couple of days in class. And in order to work with a trigonometric ratio, we first have to determine what sides we're given and what information we're given within our triangle. Now, an easy way to do that is, one, we're going to find our hypotenuse first and foremost. Okay? That hypotenuse is always across from what? It's always directly across from our right angle. So there's our hypotenuse. The hypotenuse never changes. It is always across from the right angle. But sometimes our angle that we're given, it changes location. So therefore our other two angles might change. Okay? So let's say we're given this angle. And that symbol that you see there, that's called a theta sign, and we'll use that one when we start talking about the inverses of these trigonometric ratios, but we're not going to get into that today. They're going to give us some angle measures there. So if we're standing here and they give us 40 as an angle measure, and they want to find one of these side lengths, what we need to do is we need to determine what side length is given to us, if it's the hypotenuse, if it's the adjacent side, or the opposite side. So if we're given this yellow angle and we want to know whether that is adjacent or is it opposite. Well, what does adjacent mean? Adjacent means next to. Is this side next to our angle? It is, so that's the adjacent angle in this particular example. Now we also have the angle that is directly opposite that. Okay, that, not the angle but the side, that is our opposite side. And now this will all make more sense as soon as we start seeing some examples, but we have to know how to identify our opposite, our adjacent, and our hypotenuse side lengths in these trigonometric ratios. So here's another example, and here we're given information on this angle. Now, where's our hypotenuse? That's right, always opposite our right angle. Our hypotenuse does not change. Now let's say we're looking at for this side right here, or we're given some information on it. Where is it in relation to the angle that we're given? It's not next to, it's opposite. So it's not adjacent, it is opposite. And therefore that makes this side length our adjacent one. Okay, so let's look at some examples right quick. And we use the term SOHCAHTOA to help us remember what in the world all these trigonometric ratios are. Now you might say, Coach Ferris, SOHCAHTOA, really? Come on. But it's very simple and it helps us remember our trigonometric ratios. Our first one that we're going to use is sine. Okay? And that sine is equal to opposite over hypotenuse. So is equal to sine is equal to opposite over hypotenuse. Ca is cosine, and cosine is equal to adjacent over hypotenuse. And our last TOA, that is tangent. Tangent is equal to opposite over adjacent. So we've got three trigonometric ratios that we need to know. And those are sine, cosine, and tangent. And the SOHCAHTOA helps us remember what they mean or how we can figure them out. Sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So let's look at this example here. We're given this angle that is 50 degrees. We're also given this side length that runs right down here. Change colors. We're given this side length that runs straight down here, and we need to find this side length. So we need to figure out which trigonometric ratio we need to use. So we stand at our 50-degree angle, we find our hypotenuse, which in this case, we're not given any information on, and we're not trying to find it, so we're not going to need it. X is our what side? That's right, opposite. And that makes 8 our adjacent side. So what we need to do is we need to figure out which trigonometric ratio we need to use, and it has to have opposite and adjacent in it. So we look at sine. Sine is opposite over hypotenuse. We don't know anything about our hypotenuse, so we can't use sine. Cosine is adjacent over hypotenuse. Again, don't have any information on our hypotenuse, so that one's out. Tangent is equal to opposite over adjacent. We've got opposite, we've got adjacent, so that's the one we need to use. So how do we use it? Well, we start by writing tangent, and our degree measure of our angle, tangent 50, is equal to opposite x over adjacent 8. Now it becomes a simple algebra problem. Solve for x. What is 8 doing to x? It's dividing. How do we get rid of it? We multiply. Okay, so x is equal to tangent 50 times 8. So we plug that into our calculator, and we get x is equal to 9.534. We want to go 3 decimal places, and that is our opposite side length from our angle that is 50. Let's look at another one. Here we're given 57 degrees here. Okay, and we need to figure out what information we're given. First thing we do is find that hypotenuse directly across from that right angle. And then we're looking for x. So is that opposite or adjacent? That's right, that's opposite. So we've got all the information we need in order to figure out which trigonometric ratio we're going to use. We want opposite and hypotenuse. Sine is equal to opposite over hypotenuse. That's the one we want. We don't need cosine, we don't need tangent. So we're going to use sine of 57 is equal to opposite x over 15. Now, how do we solve for x? Multiply both sides by 15. Use our calculator. Sine 57 times 15. And x equals 12.580. And that is our opposite side from our angle measure of 57. So it becomes easy once you know what side we're given and what information we need to look for. Let's look at one more example. Here we're given 45-degree angle. What information are we given? We're given x, which happens to be what this time? Our hypotenuse. Remember, our hypotenuse never changes sides. It's always across from our 90-degree angle. And we're also given 8, which is that adjacent or opposite from our angle? Remember, we're standing right here at this angle to determine whether that is opposite or adjacent. And it's next to this angle, so it is adjacent. So we need to look for which trigonometric deals with adjacent and hypotenuse. So as we go through, we look at sine, which is opposite over hypotenuse. Nope, that's out. We don't have opposite. Cosine is adjacent and hypotenuse. That's the one we want. We don't need tangent. So we're going to do cosine of 45 is equal to adjacent 8 over x. So now we just solve for x. But here, this one's a little different than our last ones. X is now a denominator. So how do we get it to the other side? It's dividing by 8, so we multiply x, not 8, x. Multiply x to both sides. So now we have cosine of 45 times x is equal to 8. X is still not by itself, but we can do that with one step. Divide by cosine 45. So we use our calculator. 8 divided by cosine 45, and we get 11.314. And that is our hypotenuse of this particular triangle. Now, hope you enjoyed that. Hope you understood it. We'll talk more about it in class. Remind me to tell you the important mode that your calculator needs to be in order for all these trigonometric ratios to give you the right answer.